So if we have a log, right, how else can we present that data? Well, let's take a look at this example. This data shows a trend of a line in the form y equals ax to the n. Here's what x is, and here's what y is. So, what is it going to be for log? Well, if this is what y is, then we can work out what log y is. Using our calculators, to use log, it's going to be shift and then the number underneath the fraction. Well, the button underneath the fraction. If you're using the ClassWiz calculators, you should get an answer off for these ones. 1.52. For the next one, it should be 64.3, which is 1.81. And finally, for the last value, 87.9, that's just going to be 1.94. Okay, pretty simple stuff. Now, how are we going to plot log y against log x and drawing a line of best fit? Well, all we're going to do is, instead of putting y and x on the x-axis, this is going to be log y, and this is going to be log x, alright? So, what we can do is plot all of these points. I'm just going to make this 0.5, 1, 1.5, and 2. And then I'll put, let me think. Again, same thing, 0.5 and 1, sure. All right, so 0.48, 1.21, that's going to be somewhere here. 0.70, 1.52, that's going to be somewhere here. And then here, and then here. Sorry, no, that's not going to be there. It's going to be... Okay, it's going to be something like that for that one. And then something like this, something like that. It's supposed to be linear, is my point that I'm trying to make. How do I know this? Well, kind of hinted about in the third part. In the third part, we want to use the graph to estimate a and n. If we have y is equal to ax to the n, we can take the logs on both sides to make log y the subject. So log y is going to be log a x to the n. Make sense? Now, ax to the n is the same as a times x to the n. So that's just log x to the n plus log a. And then we can take this out of the function and put it in front. And so our final answer here is n log x plus log a. I wonder what that looks like. A straight line. So, what we can do is we can say that this and this is our gradient and y-intercept. Okay? The way that we work out the gradient, because it's asking us to estimate, we can use these values. So, the change in y over change in x is going to be 1.94 minus 1.81 over 1 minus 0.9, which is the same as, if I plug that into my calculator, it should be 1.1, but let me double check. It's early in the morning, so yeah, 1.1. So now, right, I'll write this on the other side. Log y is equal to 1.1 log x plus c, right? Or plus log a. How are we going to find what log a is? We can use any two values and plug them into our equation. So, 1.94 is the same as 1.1 plus log A. So log A is equal to 1.94 minus 1.1 is 0.84. Okay? Which means that A is going to be 10 to the power of 0.84. Okay? Why? Because if there's no log, then we can assume that it's 10. Okay? And if you plug that into your calculator, you should get A as 6.9. Nice. Does that video make sense? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at this example. The table here shows surface area and volume of different spheres. Given that S is equal to AV to the B, show that log S equals log A plus B log V. So, same theory as last time. S is equal to AV to the B. Log S is equal to log AV to the B. Log S is equal to log A plus log V to the B. And then we take this out, so then it becomes log S is equal to log A plus B log V. Okay? Now, how are we going to fill out this table? All we're going to do is find the logs of this and the logs of this. We know that it's log of 10 because using the same logic as last time. So, log of 18.1 is 1.25. 1.26, excuse me. By the way, if I ever make a mistake in a video, please feel free to correct it. 1.70. 113.1 is 2.05. Which means this is also 2.05. Then 2.21. 2217. 2.34. And then 3.142 is 2.50, okay? Now for log V, again, we're just going to plug in the values. That's all we're doing. We're not doing anything too difficult yet. It's just using your calculator. How many of you have graphical calculators nowadays? Genuinely curious. The amount of people I tutor who have graphical calculators, that's quite a lot of you. Maybe they changed the syllabus, who knows. Alright, and finally I get 2.72. Right. Now let's plot that and draw a line of best fit. I'm not going to plot, I'm going to sketch. You guys are going to plot because you have pen and paper. So in my axis, we have log V, all right? And here is log S, okay? So it's actually in reverse to what they wrote here. Interesting. No worries. We know that it's going to look something like this, where this is log A, and we know that the gradient is B. Yeah? Speaking of B, use the graph to confirm that it's 1.5 and estimate a value for A. Let's do that, shall we? So we know that B is the change in log V over the change in log S, which is going to be 2.5 minus 2.34 over 2.49 2.72, excuse me, minus 2.49, which is the same as 1.4375, which is roughly equal to 1.5. And I'm going to use 1.5 for this question. How do you find out what log A is? Well, log A is just going to be a constant. So, log A plus 1.5 log V is equal to log S, right? Remember, that's the equation of the line, isn't it? So what we can do is we can plug in our values. So we know that log S is, I'm going to use 2.05, 2.05. Just makes it easier. 2.05 S is equal to log A plus 1.5 plus 2.05 times, excuse me, that should be times. Okay. And when we add it to the other side, we know that log A should be equal to 1. Why? Because it's 1.025, but they only want it to one significant figure. No, they want A to one significant figure. It's 1.05. So therefore, A is equal to 10 to the power of 1.025, which is the same as 10.59, which is equal to 10. And that is your final answer. That'll be it for today. Thank you for watching. If this video didn't make any sense, join my Discord server to ask me any questions you want. And if you want to pass your exams with flying colours, drop me an email. We can organise a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.